Hello everyone. Today we are going to see a solid state problems which is highly useful for all the exams, all the competitive exams, whether it may be a NEET, JEE, GATE, CSIR, PGTRB or whatever it may be. Let us see one by one. The first sum is the FeO crystallizes in sodium chloride type of crystal lattice. The crystals, however, are always non-stoichiometric and deficient in iron. Some cationic sites are vacant and some cations Fe3 plus ions, but the combination is such that the structure is electrically neutral. The formula approximates to Fe 0.95O. Okay, what they are asking, the ratio of Fe2 plus and Fe2 plus to Fe3 plus, and second one is percentage of vacant cation site. Options are given. Okay, how we have to do that? See, already they mentioned, okay, the compound is iron oxide. Iron oxide, in that iron is 0.95% is there and oxygen is there. So oxygen will be 100 and will be 95. Let the compound has X%. We will take it as Fe2 plus as X% and Fe3 as 95 minus X%. Okay, we doesn't know what is that in the Fe2 plus. That's why. Such that, so what we have to do it? So 2x, Fe2 plus, charge is 2 plus. So 2 into x plus this Fe3 plus is 3 plus. 3 into 95 minus x minus of 2 into what is the FeO? That is also 2. 2 into 100 which is equal to 0. Then what will be the x? If you multiply it completely, you will get x is equal to 85. This will be 3x. This 3x and 2x. It will become minus x. So if you do completely, then it become x is equal to 85. So now you come to know Fe2, x is equal to Fe2 plus, So Fe2 plus 85% you come to know. So Fe2 plus is 85 and Fe3 plus is what? So you have to substitute that in the 95 minus x. So 95 minus 85 is equal to 10. Okay, so 95 minus 85 is equal to 10. That is Fe3 plus. Okay, so 85 divided by 10 is, what is that ratio? 17 by 2. That is the ratio of Fe2 plus by Fe3 plus. From this question answer itself, we come to know this is the answer. And let's see what is the next. Percentage of vacant cation site they are asking. Cation means this one, cation site they are asking. Okay, I already said that this is 0.95. So what will be the remaining? 100 minus 95 means 5% is the vacant site. Okay, next question. The answer is A. B. Second question, number 2. A crystal is made up of particles A and B. A forms crystal closed packing, and B occupies all the octahedral voids. If all the particles along the plane as shown in the figure are removed, then the formula of the crystal would be, how it will be. You just see the A and B has given. Okay, in the crystal they are asking what and all is left over and all. See the answer now. Number of A atoms left. We need to see number of A atoms. A atoms is the bigger one. B is the orange color one. Number of A atoms is left. How many A atoms is left? 1, 2, 3, 4 A atoms left. 4 minus 1 by 8 into 4. How many all the carbons is having A atoms? So 8. So 1 by 8 into 4. 4 atoms left. Minus of 1 by 2 into 2. How it comes 1 by 2 into 2? See here. 2 atoms is left. Here and that too in the face is there. So face means 1 by 2. So 2 atoms is left. So 1 by 2 into 2. Okay, are you clear? Then which is equal to 5 by 2. Face centers. Okay, this is corners, this is face. If you see the corners and the face, you come to know. Okay, face. Number of B atoms left. 4 minus, in the same way, how many B atoms are left? 4 B atoms are left. 1, 2, 3, 4. Okay, 4 B atoms are left minus 1 by 4 into 2. B atoms are everywhere in the edges. Okay, edges only it is there. So 1 by 4 into 2. So edge center atoms. Okay, edge center atoms are there. Minus 1 into 1. Where is the body center atoms? Body center atom is also 1 is there. Okay, body center atom is also 1 is there. So which is 1 which is not at all included in the plane. So minus 1 into 1. So body center atom which is equal to 5 by 2. So both are 5 by 2. So both are same ratio means what it is? The simplest ratio formula of a crystal is AB. If it is the same ratio, then that is A is to B. That is AB. Answer is A. Aluminum crystallizes in cubic shape unit cell and with edge length 405 picometer and density 2.7 grams Celsius. Predict the type of crystal lattice. Whether it is a BCC, edge center, face or primitive, we have to see. Body or what. Okay. Density they are asking. Okay. See here, density given and the edge length is also there. With the help of the density formula, we need to find the which type of crystal it is. First we need to know the formula of the density. Density is the number of atoms into molecular weight into 1.67 10 to the power minus 27 kilogram divided by the volume of unit cells. See, density is given as 2.7 into 10 to the power of gram. It is there. We need to convert gram into kilogram. So into 10 to the power of 3 kilogram meter cube is equal to n number of atoms. We doesn't know. We need to find which type of crystal. So we doesn't know. If we come to know only, we have to fill this. So we have to keep this as a n into 27 is the density, is a molecular weight of that aluminium. Okay, 27 into, and this is the 1.67 to the power of minus 27 into kilogram. We need to change it divided by volume. Volume they have to say 4.05 picometer they have given. Edge length A is equal to given as a this one. Okay, we need to convert that as a picometer. Picometer means 10 into 10 to the power of minus 12. Okay, minus 12. Actually here 0.05 they have mentioned. Okay, 4.05. That's why minus 10 as mentioned. Okay, 4.05 into 10 to the power of minus 10 whole cube, A cube. Volume of the unit cell is A cube. So 4 whole cube, which is equal to n we need to find out. So if you do it, n is equal to 4. 4 means what is that? Answer is the C. What is that? A face-centered cubic lattice. The addition of calcium chloride crystals to the potassium chloride crystals. What will happen? If calcium chloride crystals added to the potassium chloride crystals, what will happen? It lowers the density of the potassium chloride crystal or rise the density of the potassium chloride. It does not affect the density or increase the Frenkel defect of the potassium chloride crystal. What will happen? See here, if you add as calcium chloride, it leads to the removal of 2K plus. Okay, this is Ca2 plus, this is K plus. Instead of 1 Ca2 plus, 2K plus will be removed because of the ion. Okay, because of the, it will be, we have to maintain the electrical neutrality. Okay, that's why it should be maintained. If 2 is inserted means 2 have to go out. 2 plus ion will be go out. So this is K plus is there. So 2K plus is going out. Atomic mass of, if you see the atomic mass of this 2K plus, it becomes 36. If you see the atomic mass of the calcium 2 plus, that is 18. Okay, actually you know, this is 20. 1 is 20, calcium is 20. If 2 plus means 2 will go, then again it become 18. So okay, so the addition of calcium chloride, what will happen? Lowers the density of potassium chloride. If you see the mass of these two, if you add this, 2 will be going, 2 K plus is going means what will happen? 36 will be going, 36 of mass is reducing. Okay, but if you add up this, only 18 is adding, but 36 is going, extra 18 is also moving. So what will happen? The density is reducing, mass is reducing, the density is also reducing. So answer is A, lowers the density of the potassium chloride crystal. Next one. A sample of a crystalline solid scatters a beam of X-rays of wavelength 70.93 picometer at an angle of 2 theta of 14.66. If this is a second order reflection, calculate the distance between the parallel planes of atoms from which the scattered beam appears to have been reflected. See, the X-ray of wavelength lambda is given, angle is given. This is the second order reflection. N is also given, N is 2. So distance between the planes they are asking. Okay, the sign calculations also, for using a calculation, the value is also given. So we need to do the calculation. What is the formula? Bragg's equation. N lambda is equal to 2d sine theta. So what is the N? Second order reflection. So N is a 2. 2 theta. Sorry, this is 2 theta value as given. 2 theta is equal to 14.66. Okay, 2 theta is equal to 14.66. What about the theta? Theta is equal to 7.33. Okay, here comes to here. Okay, n lambda is equal to 2d sine theta. Lambda value is also given. See, d is equal to, we doesn't know the the distance, where they are asking a distance. Okay, so d is equal to, we change the equation, is equal to n lambda divided by 2 sin theta is equal to, n is what is that, second order reflection, so 2 into lambda 70.93 into 10 to the power of minus 12 divided by here 2 into sine theta is given. What is the value of theta? 2 theta value is given. So theta value means 14.66 divided by 2, which is 7.33. So that is also given. See here, sine 7.33 is value is 0.1276. With the help of this, if you calculate it, you will get it 556.3 into the power of minus 12. Minus 12 is picometer. You can directly write it as picometer. You just check where this answer is there. 556.3 pm. 3 picometer. So this C is the answer. We will check. C is the answer. Next sum is, which of the following statement is correct for a two-dimensional hexagonal close packed layers? Each sphere is surrounded by 6 spheres. Each sphere is surrounded by 6 voids, or each sphere has 3 voids. Each void is surrounded by 3 spheres. What will be the answer? Which are all the statement is correct? We need to find out. See, this is the hexagonal close packing. Okay, two-dimensional hexagonal close packing is there. What is the first one they are asking? Each sphere is surrounded by 6 spheres. Each sphere is surrounded by 1, 2, 3, 4, 5, 6 spheres. Yes, that is right. Each sphere is surrounded by 6 voids. See, each sphere is surrounded by 6 voids. 6 voids also there. Yes, that is also right. Each sphere has 3 voids. Each sphere is having 3 voids or what? Each sphere is having 3 voids? No, that is not there. And each void is surrounded by 3 spheres. Each void is surrounded by 3 spheres. Yes, each void is there here. Here 3 spheres are there. That is also right. So what are all right? 1, 2 and 3. We need to check what is that. Okay. Effective number of atoms in a hexagonal unit cell is equal to how much effective number of atoms are there? 1 by 3 into 6. 6 is there. Okay. 6 plus 1 into 1, which is equal to 3. It will get 2. 2 plus 1 is 3. Effective number of voids in the hexagonal unit cell is, how many voids are there? 6 voids are there. Okay. But each sphere has how many voids? 2 voids. So 2 by 3 means, okay, 3 is there. Okay, 6 by 3 means 2. 2 voids are there. So each sphere has how many voids? Each sphere has 2 voids. This is wrong. What is that? 2 voids is right. So C is wrong. Another everything is right. So 1, 2 and last one is right. What is the answer now? D is the answer. Find the angle between the 0, 1, 1 and 1, 0, 1 plane. Angles are given. We need to find the angle. If the angle between the two planes means, this is the formula. So all the sums are differ from each other. Each sum is varied from other. I am not repeating any sums. Okay. So go through till the end. So it will be highly helpful. All the sums are different. Cos theta is equal to h1, h2 plus k1, k2 plus l1, l2 divided by the root of h1 square plus k1 square plus l1 square into h2 square plus k2 square plus l2 square. So we need to calculate the two planes. One is h1, h2, h1, k1, l1, h2, k2, l2. Okay, this is their plane. So we need to substitute that. So in all the places, these three values, if you substitute here, you will get 1 by root 4. So cos theta is equal to 1 by 2. So theta is equal to, what is the value? 60. 60 is the answer. The next sum, answer is A. Diamond has face-centered cubic lattice. There are 2 atoms at 0, 0, 0 and A by 4, A by 4, A by 4 coordinates. The ratio of the carbon atom bond distance to the edge of the unit cell is, these are all the options are given. Distance between okay, see here, the distance between these two is 2r. Okay, this is already they said as face-centered. Face-centered cubic lattice means that is a 2r only. So 2r is equal to root of 3a by 4. So if a comes here, 2a by r means root 3 by 4. It becomes root 3 by 16. If it becomes a root means it becomes 16. So what is the bond angle? Bond distance is 2r. Okay, because there is a face-centered lattice. The answer is A. Ninth sum. A cadmium oxide has a sodium chloride structure with a density 8.27 gram per cc. If the ionic radius of O2 minus is 1.24 Armstrong, then determine the ionic radius of cadmium 2 plus. Okay, options are given. So density is density, with the help of the density only we have to find. Okay, ionic radius. How they are doing? This is completely different. You just see that. Okay, density is given. So Density same means with the density formula only we have to find it. Density is I have to mention as it is. Okay, and number of formula units. Number of formula units is 4 into molecular weight is molecular weight of the compound is they have mentioned here. Okay, so that is 128.41 into 1.67 into the power of minus 27 divided by volume of the unit cell is A cube. A we need to find out. A is equal to what is that? A is equal to, we need to find out as this A cube is there. So from that we need to find the A. A is equal to 4.70 angstrom. Okay, if A is equal to 4.7 angstrom means we need to find the radius of 1 they are asking, ionic radius of CD2 plus alone they are asking. So 2 into R CD2 plus R into O2 minus, which is equal to A. Okay, the A means what is that? Length, that is the length of the cube. So length of the cube means both will be the radius of this and this belongs to the length of the cube. So the radius of this plus radius of this is equal to 2. Okay, that's why they say 2 into radius of this is equal to A they are saying. A which is A is equal to 4.70. So 2 into 4.70 divided by 2. If the 2 comes here means what will happen? It becomes 2.35. The radius of cadmium 2 plus radius of oxygen 2 minus, which is equal to 2.35. Okay, what will be the radius of this one is given. Radius of ionic radius of O2 minus is 1.24, that is given. Okay, so if you subtract it, you will get the radius of cadmium 2 plus. So with the help of the density also, we can able to find the radius of each ion. Okay, the volume is given. The volume is A cube. From that, we have to find the A. With the help of the A, we need to find the radius of one ion. Okay. Next sum. The answer is B, 1.1 angstrom. Next, the molar volume of potassium chloride, sodium chloride are 37.45 ml and 27.94 ml respectively. Find the ratio of the unit cube edges of the crystal. Okay, the volume they are asking. See here, the volume of the unit cell of KCl and sodium chloride and potassium chloride. So we need to find the ratio. Ratio of this means we need to make it as a division like that. Volume is A cube of potassium chloride divided by the A cube of sodium chloride. Potassium chloride is 37.45 and sodium chloride is 27.94. We need to divide these two with the help of cubic. Both will be a cube. So 1 by 3 they have to. If you calculate, and you will get 1.1. Okay, what is the answer? The answer is C. Subscribe my channel, click the bell button and share to your friends also. Thanks for watching.